stage is yours.
Yeah. Thanks, Stefan. I will start, and then so while Patrick gets ready. Just for the ones that don't know me, I'm Tobias Sommer. I'm responsible for the pre-sales for Cumulocity in Asia. And today, together with Patrick and Yoshi from Takebishi, they will introduce themselves. We want to show a little bit of a more advanced scenario, how we use this combination of thin edge plus Takebishi, or rather actually how a Cumulocity partner used it, more or less on their own. Of course, like both Takebishi and also myself, we sometimes supported them on questions, but they did this project on their own, and it was their first Cumulocity project, it was their first thin edge project, and it was their first device gateway project. And it was a quite interesting success. Just to give you a bit of idea what this project was about. So we're talking about connecting assembly line. And the challenge that they essentially had is that if you imagine an assembly line and you have the kind of piece that is being assembled, it's going through basically all these stations and stuff is added to it, so it gets constructed. At every station, you have sensors that check the thing, but the sensor values only have really a meaning if actually there's a piece in the station. So reading now every second these sensor values, or every 500 milliseconds or whatever, would generate a lot of garbage data because it doesn't really matter. So instead, what they have proximity sensors in every station that really tell you if there is something. And so they needed this kind of logic that enables them to say, okay, I want to read the sensor data only if there's a piece of equipment in the station, and then reliably transmit that through complex and very unstable VPN connections from the factory into the cloud. And that one will be the focus for today. We did a session around, like in general session, how these two pieces of software, the thin edge and the device gateway from Takebishi, work last year. If you missed that, don't worry. Patrick will do a short summary. If you want the full detail, I forgot which thin edge meetup it was, but one of the in the last year where they're a bit more detailed about the general setup and how it integrates with the different thin edge functionalities. So today it's really more about how to actually apply that in a real world scenario in a real project. And with that, I would hand over to Patrick.
Thank you so much, Tobias. Thank you everyone for having us here today. My name is Patrick Hurd. I'm coming from Takebishi. As sort of introduced just now, I want to get into sort of use case and demo a couple of patterns and things that you can do with thin edge, and then also with Cumulocity and device gateway altogether. But first, I'm just gonna, I know time is limited, but I'll just try to go quickly through a introduction about who we are, sort of what brought us to use thin edge and Cumulocity, and then get into the demo. Okay, so Takebishi as a company, we are based in Japan, in Kyoto, and this year we are celebrating our 100th anniversary. So our main business is trading and using our affiliation with Mitsubishi Electric and distributing their products. So as I said, we're based in Japan, but we do have a large footprint both domestically in Japan as well as in Asia, and then globally as well. And I think that up until now, from the description, it wouldn't make a lot of sense why we're working together closely with Cumulocity and with thin edge. But in addition to our sort of trading activities, we are also developing our own technology. So within our technology division, we are developing our own products. We are also doing some system integration work, and then also doing consulting and factory automation, sort of bespoke solutions. So our sort of journey in the original product space started about 30 years ago when we were developing drivers for Mitsubishi Electric. And then this brought us then to now 7 product versions later and a whole lineup, mostly focused around IT/OT convergence and trying to take data from the plant level and bridge it up to systems where it can be analyzed, utilized, and visualized. In general, then, we're existing here in the middle, where we are then bridging various vendor protocols, whether that be robots, PLCs, sensors, what have you, into then a standard format that can be utilized all in one place by upper-level cloud systems such as Cumulocity, whether that be via OPC UA or MQTT REST as well. And in this 30-year journey, basically, we have been able to distribute our products to a large number of countries, and we're looking at just under 60,000 units sold. So this is a big focus of ours, and we do have a good deal of experience in it as well. So when we talk about how we started working together with ThinEdge and with Cumulocity, it's going to center around one specific product, which is our device gateway. So this is an IoT gateway that, as mentioned before, is going to take data from production devices and then bridge it up to cloud or other MES dashboard solutions, such as Cumulocity. And the big sort of points that are going to set it apart are going to be the large number of drivers, looking at over 300 series of device from multiple vendors of PLC. So being able to translate all of the data from those devices in one interface. And then in addition, this is distributed as both a hardware and a software model. For today, we're going to focus more on the container Dockerized version. We don't need to list everything, but again, with the connectivity, we are able to communicate with a large level of devices, and some of the major ones are listed here. Most standardized protocols and vendor protocols we're going to be able to work with. One of the other things that kind of sets apart the device gateway specifically is going to be the simplicity. So it's all browser-based, so you don't need to do a large amount of programming. Everything is pretty simple icon-based action. So just setting up the connectivity, and then as well as logic. So you can integrate some logic without coding as well. And I'll demo all of this later. Getting into the logic again, from the browser, you're able to just sort of implement a series of logic without having to do any actual programming. And when you're then using ThinEdge to communicate between the device gateway and Cumulocity, this gives you a really good base where you're able to then put in the triggers and actions in order to put together the system that you need without having to get in the weeds on the command line. And then this is just showing a sample sort of cycle, and I'll get into more of that in the demo. So then, as I said, we have both the hardware and the software model here. The hardware is a certified Cumulocity device. And then the Docker container model is, I'll show an example of it today, working together with ThinEdge to bridge data to Cumulocity. With the software model specifically, we're looking at this container on Docker living within the hardware gateway of your choice if you already have your hardware picked out. Again, that's going to be able to take the data from the device level and then interact as well with other applications that you may have developed. In this case, we're talking ThinEdge. So here we have the idea, the architecture of where ThinEdge and device gateway are able to work together to kind of give an all-encompassing solution for production data. So here we have then the Docker container as well as the ThinEdge existing on an IoT gateway device, as well as the local MQTT broker. And then from there, you're going to be bridging the data to Cumulocity, where you can then visualize and manage your devices. So as Tobias had mentioned, today I wanted to show an example based on a project that we had in Japan. The idea being a production line for, in this case, refrigerators, where you have various stations, each running with its own equipment, and then sensors running data in each station. And then you only really want to send the data to Cumulocity, sorry, for the station that is currently in progress. So kind of mapping our solution and what we're going to be showing today. So we have our assembly line, and then we have multiple stations set up. Each station is going to be represented here by a PLC. So we have Siemens, Mitsubishi, and then Rockwell as well. That is then being sent to the device gateway. The device gateway and then the thin edge are both going to be existing on a Raspberry Pi. So just a very sort of simple setup. And then bridged to Cumulocity. So I have two scenarios that I want to demo today, and we can go just one by one. So the first one is going to be just showing the visualization of the data for each station. So as we mentioned before, we have these three stations. Each is going through part of the progress of producing that refrigerator. And after each station is complete, the product is then going to move along the line to the next station. Then we have a switch setup, which is going to be monitoring what station we're currently at and what station is active. And then when the device gateway notices and detects that we've moved to a new station, then it's going to send the data of that station via MQTT to Cumulocity. All right, so I'm going to pull up our other screen here. I see that that is okay. Okay, so what we're looking at here is the device gateway screen, the window. As I mentioned, this is available just by the IP address on your browser. And here we have the data source menu. So we have all of our different PLCs here. So I've set up some of these PLCs already, but as I mentioned, it's pretty simple to get connected. So from the configuration screen, you're basically just going to put in the IP address, the port number, and be ready to communicate, right? And then as well, you can create tags. So you can create tags as well, and those will be sort of laid out. You can make your folders, and you can make them all viewable as well. So once you have your device connected, you can then get connected to thin edge, right? So we have a couple different IoT interfaces that you can connect with here. OPC UA being a major one, FTP as well, and then HTTP REST API if you want to do databases. But for here, we're going to stick with the MQTT and the thin edge client. So this is going to be on the local broker, and then you just specify your device name and your client ID. And then thin edge really makes that easy to get all of the data then pre-structured and formatted once it gets up to Cumulocity. So this is a pretty simple connection, and then you're ready to go and start working. So now that we have our device set up and we have our connection to thin edge, we need to start choosing what data gets sent. So that's going to happen here in the event tab. And basically, in our event here, we're sending data. So in this event, it's done by specifying triggers and then actions. So our trigger here is going to be a cycle of 10 seconds. So every 10 seconds, the device gateway is going to go through this series of actions. So if we just go in order here, we can see this first action is going to be comparing a value. So what we have here is choosing which value to compare, and this is the switch value, which is showing us which station is currently active. And then we have here if that switch value is at 1, so we're in station 1, then we are going to move to the next action. And if it's not, then we're going to skip ahead to compare to, and this will make more sense as we get back. So we had our compare 1 here, and if the value is 1, then we're going to move over to the first send here. If not, we're going to move down the chain here. So let's look at what we're sending. So if the value is 1, if we're in station 1, we are going to then send to the thin edge this measurement. And this measurement is the combined sensors that are active in station 1. And then it goes through the same chain for station 2 and then station 3 as well. So that's just one action that is then choosing which of the station's data to send. And so we can then go into our Cumulocity cockpit here, and we just have a simple dashboard reading out. And it is showcasing what station we're in then. And then, as you can see, we've then moved back to station 1, and that data is then going to be shown live here, right? So we can see that only the station that is active, and since it is on that 10-second delay, it is coming a little bit later in here. But we are then going into station 1, right? And so then we're able to sort of only be sending, we're able to be sort of economical about what data we're sending, and then also make it easier to visualize what we're actually looking at in terms of the station data and the status of production. So that's the first example. Here, let me move back then to my slides. And then in the second example we have here, we're going to then show some alarm capabilities. So in this case, we have our PLCs connected showing our station data, but we're going to see what happens when we then have a communication failure from our PLC. In that case, the device gateway is then going to detect that and then is going to send an alert to Cumulocity. So let's see what that looks like then. So for that, we're going to be using this error detection script. So the device level and the connection are the same. In this case, we're going to be, again, just looking at a cycle of 10 seconds just to trigger that action and to see what the current status is. And in this case, we're going to be looking at a value from our PLC. Just one second. All right. And we're going to be looking at the status value. So the status tag in our PLC is going to be telling us the quality of the connection. And then if that value is 0, indicating a bad quality of connection, we are going to move on to our next action, which is going to be sending then an alarm to Cumulocity via thin edge. And then that will be putting in the status of the alarm and then our message of choice. And this is all in the thin edge documentation in terms of how to structure that message. So in order to sort of trigger this, I have my PLC here, and I'm just going to change the IP address just to quickly sort of simulate that failure. So when you're doing the communication changes, again, it's all via the browser, and then you just need to save to apply the changes to the Raspberry Pi itself, so that we can put this into production. And this is pretty quick. The Raspberry Pi itself is obviously not meant for production, so it takes a little bit longer just in that sense. Okay, so let's see. So now the connection here has been interrupted, and then we should see momentarily here that we are going to be then getting this error. Yeah, so this communication error is then this communication error then is popping up on our dashboard as well. So that is then the second use case. Again, simple, but also based on some projects that we've been putting into practice for some of our customers. And yeah, so that's all that we have to sort of show today. And then we can also open it up for questions. I don't know if we have a couple minutes left.
We do.
Yeah, thank you.
That's a question by Chris. Go for it, Chris.
Thank you. This is super interesting. I was curious whether you've had any experience with training of data, like in a federated learning setup or something like that. And if you have, perhaps what bottlenecks you faced.
Absolutely, thank you. In terms of, on our side, training data in terms of like for developing of models, or I'm sorry.
Yes, like perhaps one of your clients wants to actually develop models. And so because you're, I guess it sounds like you're central to that process between actually having the devices at the edge and having it sent to the cloud, whether it's, yeah, Cumulosity or whatever else.
Absolutely. So Tobias, I'm not sure if you want to also the Cumulosity side, but are also involved in developing some sort of AI models and training the data from that sense. I think in terms of the collaboration with ThinEdge and then the device gateway and Cumulosity, we are in the process and make it very simple so that you can then train the data on your end, I think is what we are sort of enabling, I think. And then you would be able to sort of filter it into the area that you want. I'm not sure if that answers your question fully, or if maybe Tobias has something to add.
Yeah, maybe I can add a little bit. So like from the Cumulosity perspective in general, so we have done or we have supported customers with this process of training mainly through our professional services. The problem is always with like training models, it's like super specific. So like the focus on the product side is really much more collecting the data and bringing the data into a format and into a structure that it's actually usable for training. So much more the base. So in Cumulosity, there's no specific training tool or something like that. I think anyways, nowadays the world of machine learning training is very open source driven. And that's also what we see with our customers. And in certain projects, yes, we support them as kind of a consulting service, much more than as a product solution. I hope that answered the question.
Yeah, thank you. Oh, sorry, follow up. So in that context, were you sending, because I'm seeing here like different communication protocols, like did you have to make any changes in as far as what kind of communication protocols you're using, or it was whatever was already there, but it was more just opening up that for the client to be able to use when training their models?
Yeah, that is a really good question, because for the customer, it's really if like let's say the data scientists of the customer, they don't care about the protocols. They just want the data, and they don't want to worry about if now the certain sensor value comes from a Mitsubishi PLC and the other value comes from a PS-System smart box. So they like the data scientists don't care. So like the way we support mainly is about this normalization of the data, so that the data scientists in the end, they just see data and they no longer need to care about where it's actually coming from, because it will all look the same.
Thanks. Thank you so much.
There's another question by Aaron. Aaron, you want to ask it yourself, or should I read it out?
Yeah, sure. I can also ask myself. So the question is, what are the most relevant verticals for you? Where do you see the device gateway being mostly used, like utilities, manufacturing / shop floor, or are there any others that, yeah?
Absolutely, thank you. Yeah, I think manufacturing is where a lot of people start thinking about first, because there a large amount of vendor-specific programs. We have a large sort of need, I think, for especially a gateway that can be plugged into sort of legacy systems without having to overhaul and update and sort of start tearing everything else that we can add in our sort of connectivity solution. So manufacturing is big. The demo today was, I think, obviously structured around a manufacturing line. But yeah, energy is a big growth field as well, and needs a lot of monitoring, right? Whether that be sensors and be aggregated. Also facilities building, where you have protocols. I think that came up before, right? BACnet, Modbus, things like that. So really any field that needs data and it's coming from, you know, a wide source of vendors is going to be a good case for, as Tobias was talking about, normalization of that data, where, you know, it would be easy if every device within a facility was all from the same vendor and was all speaking the same language, but it's usually not, and it's usually not the same version or the same firmware. So we need to be able to get everything on the same page, hopefully as close to the device level as we can.
Thanks.
Okay, are there any other questions? 3, 2, 1. I don't think so. Last chance. If not, I want to thank you all the speakers again, especially our guest speakers from PSysTech and Tekabishi, of course. Thank you for having very great and insightful presentations. Yes, let's close the call. Thank you very much for attending, and hopefully we see you in one of our next Tech meetups.